What up, guys? We're gonna be looking at exploring some darknet stuff and looking into the problem with IPv6 is what is IPv6. I'm looking at this project that just came across. And what other better way is to radical get Codeberg. Talking about free. Codeberg is a non-profit community level Git hosting other services for free and open source projects. All right. Based. Interesting. I should start warning people that I'm going live ahead of time. I don't have a set schedule either. That's my first red flag, I would say. Lack of lack of actual scheduling. Oh, I didn't change the fucking chain. Gotta get rid of that fucking thumbnail. Step 1. I think my typing's gotten better. Faster? Maybe? Or maybe I'm just dumb. Maybe. Well, I'll be Dimmadome. Welcome to the good old Dimmadome. So there's something called that someone slid across me. Not the schizoids that are like, use this project. So this is going on for 5 years. That's crazy. CJDNS implements an encrypted IPv6 network using public key cryptography for addresses, allocating the distributed hash table for routing. This provides a zero configuration networking and prevents many of the security and scalability issues that plague the existing networks. Ooh. Oh, Rust. Rust is involved. Based. Interesting. What's up, Uncommon? How you doing? I'm looking at a cool thing, and then we're going to look at other cool things and maybe get people's gears turning. I'm really on a self-hosted kick. So the problem with IPv6 is there is some theory that IPv6 is somewhat more identifiable because the lack of use case and there's too many ways to inconfigure it, and because it can be inconfigured incorrectly. There's a lot of problems that arise with it. There might be even higher chances of leaking sensitive information / data. This is why that most people just say disable it. Are we having cool things today? We are having cool things today. It's always a good time to have cool things. But this looks like something called this is kind of like maybe a solution to it. It's kind of interesting. It's called CJDNS. CJDNS is an encrypted IPv6 network using public key cryptography for addressing and allocation in distributed hash tables. This is kind of how the Requiem network works. What up, Thecon? And because we have the ability so this is how the Requiem network kind of like works. It uses public key and private key cryptography, even over LoRa, even over TNC, even over a KISS, even over like IP, I2P, etc., etc. It uses public and private key cryptography. So that's kind of cool. This has Rust involved in it, so I'm immediately interested. And C, so C and Rust also based. JavaScript, unfortunate. Python, very unfortunate. PHP, Icon. Oh, the Icon 2020. What about the Icon? Is it the Icon or the Icon? That's the real question. So it implements an encrypted IPv6 network. IPv6 has been around for a long time. It's supposed to solve IPv4 issues with scaling, yet it still hasn't replaced a lot of things. We still rely on IPv4 because they theorized that we would run out of IP addresses. And then so there was something I was supposed to CGNet, carrier grade net. I was supposed to look at that. The or the? I don't know. I don't know the difference. Are you saying the or the? So we'll kind of like look at that too because it kind of correlates to interesting. And then we're going to explore kind of like, I guess, GitHub. Here's the white paper and the project goals. So we can kind of get out of this part. I do like looking at code review, issues, code spaces, explore. Maybe explore? No. No. App modernization. Resources. Topics. The or the? What is AI apps? I don't give a fuck about AI. There was a section. Find more, search less. Oh, this is what it is. Maybe code search? No. I thought you could look at like trending repos. Maybe I just gotta do this. Ooh. Oh, that's what it is. There we go. GitHub trending. I used a GitHub repo to find the GitHub place I need to be. Open source frontier void. No, that's kind of gay. The only bad thing is I hate coming onto this slot place. Is yo Rust, a text editor for your terminal? And then we can look at F-Droid. F-Droid is kind of. I know that sounds kind of crazy. I like F-Droid for one reason. I get to find just really random, specific, free and open source Android apps out of nowhere. I'm like, wow, this looks interesting. That was a meta ass move. Yeah, the AI fucking shit is. But if you want just to find cool shit, even if you people agree or disagree with F-Droid's like how they do their updates and everything, whatever. There's so many cool apps I've just found like for no reason. I'm like, this is awesome. I need to use this, and I'll use it, and then I'll end up liking it. Like, why the fuck wouldn't you want a birthday calendar that's developed as some college student just chilling? Amaze open source file manager following material design. I do like material design. Material design is based. Application for collecting wireless networks and geo. This is a cool app I've used before. Personal activity intelligence calculator. Like, there's just sometimes I find something, I'm like, this person only made this because they needed it. OpenDNS updater, virtual host for Android implemented by VPN mode supports wildcard DNS records. Like, just crazy shit. You can do org, live your life in org mode, take it with your Android device. Orgo, Hexvir, Hexadenavir, draw, stuff like that. Where's the local media player? I like the word local, but we're gonna go back. We're gonna go back to the purpose. The first step one. I will say permanent dark. Like, everything needs permanent dark. Dark mode, light mode should just be fucking erased. We should get rid of light mode. So what? Imagine internet where every packet is cryptographically protected from source and destination against espionage and forgery. Getting an IP address is as simple as generating a cryptographic key. The core routes move data without a single memory lookup, and denial of service is a term read about in the history books. Finally, becoming an ISP is no longer confined to the mighty telecoms. Anyone can do it by running some wires or turning on a wireless device. This is the vision of CJDNS. That would be kind of based, actually. The internet is built on protocols which largely date back to the 80s or earlier, at a time when the networks of anarchist academics and scholars showing the ITU that open standards matter, and it was absolutely enough. Over the time, networks have gotten bigger and users have found new needs. In the age where packet inspection is universal and security breaches are commonplace, cryptographic integrity and confidentiality are becoming more of a requirement. The U.S. government recognizes the requirement and has been helping through IPsec and DNSSEC efforts. I think, from a privacy standpoint, DNSSEC. I think that was the point people said the encrypted client hello from David, who is a plumber. He said that it's more private than a VPN, and it's not. But I think DNSSEC is more of a security thing. It's been kind of discussed already that DNSSEC is more of, if I'm and encrypted and client hello is not supported everywhere either. They're more of better security than privacy. Like, they help against forgery and you going to phishing sites. If I remember correctly, I would have to dig deeper into my. I only have a terabyte of memory in my brain, so less than terabyte. I have 128 gigs at this point. No. Forget what I said about having better typing. DNS is a domain system security extension. It's a set of protocols designed to protect the integrity of data exchanged in the domain system by using cryptographic signatures. It helps to ensure that the response to DNS are authenticated and not been tampered with. I think that's really what my brain was alluding to, that it's more of a security thing than a privacy thing. I mean, which could, I guess, lead to better privacy, but he was saying, like, oh, it's more private, and people will, like, fact check them. They're like, you're wrong. Because your ISP can still see your websites you're going to if it matters. But I digress. Back to in IPsec. Another issue is how we're going to route packets in the world where global routing table is simply too large for any one router to hold it all. Despite the heroic efforts of the core network engineers, the growth of the global routing table seems to be an unstoppable march. Cisco Router Company has proposed a plan called Locator Identifier Separation Protocol, or LISP, which aims to, it helps to protect man-in-the-middle type DNS text, but doesn't really help with privacy. Yeah, I figured that it was not really a privacy enhancement, and I think people have said, you have to ask yourself a question: do you need DNSSEC or do you need an IP, a VPN? Do you need a VPN or DNSSEC? And it was kind of like if you answer yes to this, it's like you don't need it. If you answer to this, then you need it. I think some VPNs kind of help against phishing. I'm not entirely sure. There's probably fucking like answers to this. Oh my god, Batman is so cool. I discovered this years ago, and I wish it was a fucking thing. Batman is based. Hopefully. I accidentally messed up my OS deleting one of the main packages managers, and then I installed the OS and set it up in Podman desktop for my VMs. That's cool. Yeah, Podman's pretty sick, actually. I use Portainer because I'm a boomer, apparently, now. I like Portainer. It kind of just works. But Podman's cool. I looked into it. Even though OpenSUSE makes OpenSUSE makes something called what's Batman? Oh, you're about to get your nuts wet. Batman is super cool. It's called the Better Approach to Mobile Ad Hoc Networking. It's 20 years old, by the way. Put this into perspective. Is a routing protocol for multiple hot mobile and ad hoc networks, which is under development by the German, I can't pronounce that, community, and intended to replace optimized link state routing protocols, OSLR or whatever. OSR did not meet the performance requirements of large-scale mesh deployments. Batman's crucial point is the decentralization of knowledge about the best route through the network. What does OpenSUSE make? I've moved to Dokoploy. Works similar to Portainer. Oh, interesting. I'll check that out. OpenSUSE makes something called they make a hypervisor, not that's like Rancher. Damn, my ADHD's kicking in. But OpenSUSE, what's it called? It's really cool, but I ran it, but it's very resource. Harvester. They changed the name. That's how long it's been. It was called Harvester. Harvester was cool. I ran it. Super fucking heavy compared to Proxmox. But if you wanna actually go down a virtualization route, here's the link. Back to Batman. Batman's crucial point is its decentralization of knowledge about the best route through the network. No single node has all the data. This technique eliminates the need of spread of information about network changes to every node in the network. The individual node only saves information about the direction. It receives data from and sends data accordingly. The data gets passed node to node, and packets get individually dynamically created routes. A network of collection of intelligence is created. In early 2007, the Batman developers started to experiment with the idea of routing data link layer 2 in the OSL model, rather than the network layer. And to differentiate from layer 3 routing, Daemon, the suffix ADV for advanced was chosen, instead of manipulating router tables based on information exchanged via UDP IP. I can feel the ADHD from here, for real. Canonical multipass is very cool too. I'll have to check out multipass. Based on the information exchange via UDP IP, it provides a virtual network interface and transparently transports Ethernet packets on its own. The Batman ADV kernel module has been part of the Linux kernel since 2.6.38. Operation, version 1, version 2, version 3. Batman experiment aims to provide a real exponent, also sending OGMs multiple times, independent broadcasts. It's just a different way how they want to do the network, and they want to make it decentralized. So in addition to radio networks, Batman can also be used with common wired cables connections such as Ethernet. It can be used and it's considered a more decentralized and high resilient ad hoc network, hence the name, better approach to mobile ad hoc networking. It's very cool. In static networks, network administrators or technicians decide which computer is reached via which cable, and radio networks undergo constant changes in low participation thresholds are a vital part of the Free Funk Networks Foundation, and this task has been automated as much as possible. It's pretty cool. The task was created to create a protocol which would be as easy and small and fast as possible. It seemed to be sensible to split the development in several phases, implement it. I think we're probably on version 3 by now. When was the last update? The last update was 10 months ago, which is pretty decent in like something like this. It's been going on for 20 years, but just because something is going on a long time doesn't mean it's going to get adopted immediately. Okay. So it's always easier to show you the real unique IP addresses if you already have a network. Denial of service, an attempt to prevent legitimate use from accessing service, is likewise a new problem in the expanding network. To many knowledge, there is no general purpose solution to denial service attacks. Solution to packet flooding based denial service attacks often resolve around hosting and service on many computers so they can handle enormous amount of traffic. That is kind of true if you think about it on a logical sense. The denial of service is one of the oldest forms of attacks, and it's still prevalent today. It takes down some of the largest networks. It takes down large websites. It takes down lots of things. It's used, and then with automation of botnets, like pretty much you can just buy them now, and IoT devices becoming way too big. I mean, they literally get grabbed and put into botnets all the time. So this is not a good thing. And because the larger these botnets get, the larger denial of services get. And denial of service, again, they're very effective. Also, another problem that we need to solve, no offense to Cloudflare, we're way too reliant on them. There's so many services that just go out because Cloudflare does the wrong update. Or imagine if Cloudflare went down tomorrow. Most of the internet would be fucked. A lot of the internet would be fucked. It's a huge problem. Cloudflare runs too much of the internet, in my opinion. I don't care how well they do it. They just have way too much control. And there's not there's not enough redundancy. The internet is like paperclip and string away from always collapsing. And I mean that with sincerity. We're too reliant on them. Just how I view it. Finally, the existing protocols are difficult to use. We cannot reasonably assign blame to anyone for this. Many of these protocols are often over 30 years old and demonstrate a level of craftsmanship which I can only hope one day achieve. However, 30 years takes its toll on the best of us, and as the internet grew, it became more complex. The administration interface of the typical router has grown to a thicket of knobs, buttons, and switches to match the proliferation of use case and failure modes. As a result, network operation has become a science where students receive degrees and certifications for knowing the meaning of a plethora of knobs and switches. It has also become likely like the turning of race car and art passed from master to apprentice and shared on a mailing list. Suffice to say, the bare entry into the ISP realm is too high. Users, particularly in the ad hoc network arena, have observed a high bar entry of traditional routing and developed a menu of self-authenticating configuring protocols such as OLSR, HSLS, and Batman. I will say that, yeah, I mean, you can go get and you can make an entire, I know that you can say this with any field, but you can make big, huge money and an entire degree and path just in networking. Like Cisco certs are considered like one of the highest loved and sought after certifications because networking is literally, I mean, it's everything. You don't exist without a network. Most things don't. You need a network. You need to understand networks. You need to understand networks at a fundamental level. You can't skip around, like you can't just skip it and be like, let me fuck around and find out kind of thing. Networks are complicated. They are like always, like I said, you know, a snippet away from getting crippled. And you kind of, it's not just a high bar of entry. I think Jetson, whatever the fuck his name is, NVIDIA CEO, just showed something kind of insane. I think he made the highest network switch. It can, like, he said, like, these 3 switches could handle the entire internet. Yep, right here. This is crazy. The headline went to Rubian. It's Spectrum X is an end-to-end accelerated networking platform designed to improve the performance efficiency of Ethernet-based AI clusters. And accurate is going to derailing pieces analogy gone wrong. What the fuck? He like said that this could 3 of these could like handle the entire internet at once, or like one, like just an insane amount of networking that it can handle. It's crazy. What is the throughput? How much internet is... Forget it. It's like it's like in the terabytes. I guess world data. Wow, 6 billion people are on the internet. All the titties. Breaks in the data center make her nope. I remember seeing a video and he was like, the internet uses like 1,400,000 terabits per second, something like silly. And I was like, that's crazy. So the problems are already solved. Not every problem on the list has an existing solution to the ones which do. Many of the solutions are based on incompatible technologies. For example, OLSR was not designed to operate with IPsec and Lisp. Damn it. even when the solution exists and are ready for development, they still requires mass technology adoption. They don't offer existing ISPs significant immediate gains. The mismatch is rather absurd. On the other hand, there are scholars, engineers, and hardware and software designers with a combination of over 1,000 years of experience. There are mathematical formula, proofs, papers, and specification documents written, circulated, peer-reviewed, and then written once again. On the other hand, you have a single voluntary developer, a clean slate, and an attitude that nothing is impossible. How can this be anything short of lunacy? In revolutionary times, the old book only weighs you down. Wow, what a base take to actually. Guys, how would VPNs exist in this world? CJ DNS was built on the idea that ISPs and hosting providers which exist now will never upgrade. Not to LISP, not to DNSSEC, not even to IPv6 in any meaningful way. Building new systems to be compatible with old systems is catering to an audience you will never have. Asking existing ISPs to upgrade for the common good is asking them to take a risk with no immediate benefit. CJDNS is about throwing out the book and redefining the specifications in a way that will be fast, secure, and most importantly, easy for the next generation of ISPs to deploy and use. What is this denial of service? Usage of a service can be interrupted by sending a flood of unwanted packets to a host for a large number of infected zombie machines. This is known as a DDoS. It is a problem which worsens every year, and the upload speed of all the infected nodes on the internet grows to proportion to the download speed of any given link. Being infected with a virus and participating in a DDoS, though not a picnic, is not an emergency for the owner of an infected machine, nor is an emergency for the ISP. DDoS is always their problem until it strikes your network. Sadly, a common response from a data center is to stop carrying the controversial content, making DDoS an effective censorship tool and encouraging the practice. Another form of denial of service, which is even more insidious, and is intimidation by the threat of Fox court action. The form of denial of service is especially effective since most people get their IP addresses from their ISP. When their ISP is threatened, they need to make a judgment call as the validity of the claim. They often act as the judge and the jury, disconnecting a customer to avoid conflict. Those who have their own IP address signed to them are able to essentially be their own ISP and peer with multiple other ISPs, making it very difficult to threaten anyone but them. That is a good point that I have not thought about, that DDoS does kind of enforce some form of censorship, because the ISP, the node, like the VPS providers, why would they want to keep you? You know what I mean? Like, you're causing them harm, in a sense. You're causing them tons of harm. And because you're causing them tons of harm, of course they're going to not want to do business anymore with you. So, I mean, it makes sense. It's definitely there. What is the routing table? Why does it keep getting bigger? A more technical issue with the internet, and one which many people aren't aware, is address spacing degradation. Every computer connected to the internet needs an address, a number of which uniquely identifies it, which is attached to every piece of data which is to be sent to the computer. Every stop along the pathway of the internet, a packet, a unit of data, has its address filed, examined by a router, so it can decide whether the packet should be set down. Routers have an easier time if addresses are in big blocks, so the router can quickly look at the first number of the address and know, for example, this is the destination of somewhere in China. Not exactly, but enough to know which wire to send it through. People naturally want as many addresses as they can possibly get, and they want them in smallest blocks possible. This is so that they control or buy and sell these small blocks independently. The smaller the block of addresses which are announced, the larger the routing table becomes, the more work the internet's core routers must do in order to send packets to the right direction. There have been attempts to aggregate addresses back in groups, but nonetheless, the number of small announcements in the global routing table has grown every year. To address the growing routing table, Cisco has proposed a new protocol, Locator Identifier Separation Protocol, or LISP. The idea of the LISP is to separate addresses which people use from addresses which routers use. Like a lower level version of DNS, LISP allows the edge ISP and the users to see the internet as they want it. Degradation into small pieces for political reasons, and the routers to see the internet as they want it. Centralized hierarchical pyramid of addresses, emanating from some arbitrary center point. The design works well in existing routers since they can design to get packets with a universally unique address and look that address up in the table. This is advertised as a design feature, but LISP is limited in its vision. If one must look up the real location of a server before forwarding a packet, why not simply look up the fastest path? I don't care. It's their problem. Each of these problems is a tragedy of the commons problem. The users of virus-infected computers are incentivized to save money rather than purchasing products or services to rid their computer of the infection. While there are some solutions, such as ingress filtering, which decreases the problem, ISPs are incentivized to implement as little security as possible because they are not directly affected. Denial of service, whether by packet flooding or Fox legal action, benefits the attacker who is able to hide the truth or victimize service providers as well as organizations who make it their business providing DOS-related services. The victim who all too often publishes information for no other reason than satisfaction of telling the truth, the only party harmed by this type of attack is the least to be able to prevent it. Address space degradation benefits the edge of ISPs who gain more flexibility in how their network is organized at the cost of the core ISPs who only defends the "we will not route that" nuclear option, which would no doubt bring a revolt from the edge ISPs. Each of these problems hurts everyone. DDoS forces ISPs to over-provision their lines, and denial of service through Fox legal actions increase the cost of running a community website or ISP, since each accusation must be reviewed, its validity assessed and addressed. Degradation means everyone must pay more to have their packet routed, increasing high-power routers and difficulty of operating router and getting a block of IP addresses hurts competition in the ISP sphere, thus increasing prices and impending progress. How? CJDNS is made of three major components which are woven together. There is a switch, a router, and a crypto auth module. With the total disregard of the OSI layer, each model is inherently dependent on both of the others. The router cannot function without routing a small world which made possible by the switch. The switch is blind and dumb without the router to command it, and without the router and the switch, the crypto auth has nothing to protect. The switch, he doesn't think about his actions, they flow from the core of his being. What a deep philosophical perspective to have. The switch design is unlike an IP or Ethernet route that needs to have knowledge of the globally unique endpoints in the network. Like ATM switching, the packet header is altered at every hop and then a reverse path can be derived at the endpoint at any point as long as the path at any point along the path. But unlike ATM, the switch does not need a store active connections, and there is no connection setup. Definitions: interface, a point-to-point link to another CJDNS switch. This may be emulated by the Ethernet frames, UDP packets, or other means. Self-interface, a special interface in each switch. Packet sent from this interface are intended for the node which is a switch a part of upon reaching the ultimate hop in its path. The packet is sent through a self-interface so it can be handled by the next layer of the node. Director, a binary code word for arbitrary size which, when received, the switch will direct it and send the packet down a given interface. An order of a route label is an ordered set of directions that describe the path through the network. Encoding scheme, the method of which a switch converts one of its internal interfaces, e.g. array index, to a director, and converts a director back into the internal representation. Encoding schemes, may be either fixed with or variable width. But in the case of variable width, the width must be self-describing, as the directors are concentrated in the route label without any kind of boundaries or markers. Encoding from a single representation from the encoding of a director. Given encoding form, there's only possible way to represent a director or a given interface. A variable width encoding scheme will have multiple encoding forms, while a fixed width encoding scheme will only have one. Director prefix for switches which implement variables with encoding at least significant bits of the director is called the director prefix, and used to determine width of the director. Note, because the route label is read from least significant bit to most significant bit, the director prefix is actually the bits furthest to the right director. Lots of bits, lots of directors, lots of directing, lots of based. Oh, okay. This guy's been working on this for a minute. Okay. When a packet comes into the switch uses an encoding scheme to read the West. Okay. Example. Supposing Alice wanted to send a packet to Fred via Bob, Charlie, David, and Eleanor. She would send a message to her switch with the first director instructing her switch to send it down its interface to Bob. The second director instructing Bob's switch to send to Charlie, and so on. Note, spaces between the bits are for illustrations only. Router labels have no boundary markers between directional and switch. Cannot know how many bits a director uses unless the director is their own. Alice's original route label before entering the switch. Supposing Dave cannot forward the packet, he needs to send an error. He doesn't know where Charlie's director ends and Bob's begins, so he can't read the order. He can't read the order of them, but because they are bit reversed, he can reverse the order by bit reversing the entire route label. Wow, lots of bit in reverse. Routing label manipulations, interesting. Connect me to a packet if session stays equal. It's definitely an interesting concept. No. Is this Zulip? It is Zulip chat. Yes, these motherfuckers do not let you explore. So it looks like we'll do this week. RustFS is pretty cool looking. Microsoft Magnetic UI, Bun, AI Toolkit, Claude RustFS. RustFS is kind of cool. It's faster than MinIO. It's self-hostable. Don't know if it has a GUI. High performance feature as S3 core features, bit route protection, single node mode, bucket replication, lifestyle manager distribution mode, OPA. 2 cores, 4 gigs, 15 gigabytes per second. Drive 40 gig times 4. Permissive Apache 2.0 licensing. 100% 3S compatible. Strong edge support, ideal for secure, innovative edge devices. Enterprise risk mitigation. Clear IP rights for safeguard commercial use. It's pretty awesome. Pretty cool. MinIO went kind of like schizoid and closed off their like community driven. I listened to their update on their YouTube channel and I was like, ooh, yikes, I used MinIO. I'm gonna leave. So I'm gonna migrate to probably this. Or Seaweed FS. Seaweed FS is pretty cool. But this is based on Rust, guys. Let's look at F-Droid. Oh, it's just writing. VPN. Thought they had a section for just new. Obtanium, FFF updater, F-Droid nearby. Oh yeah, I forgot. Exchange free software apps locally, device to device, even without internet. This could be added as a option too. If you want to like share apps like via the repository, F-Droid nearby would be kind of cool. Exchange free software apps locally, device to device, even without internet. Calculators, just so many different cool connectivity is kind of cool. Wiki frontend is a Wikipedia app with censorship circumvention. Agma Droid, easily control your Agma 2 box right from your Android device. Wafern is the social network that respects you. Material 3 app for controlling OpenShock and Shockers. Yeah, there's so many cool like open source apps that like help you get full advantage of like proprietary stuff that doesn't really necessarily have you fantastic. Minimal Android app to stream microphone input into the local area network. Add guard, would subscribe. Home Assistant is cool. You can do a lot of like home assistant, like self-hosted options. Home Assistant's really based. Like if you want to get even more like granular control, Home Assistant's really cool. You can do a lot with it too. Integrations. There's Amazon Alexa, ESP Home, Google Assistant, Google Cast, Homebridge, IKEA Trader. I don't even know what the fuck that is. Levy's the Ashton Wave, Luracast, MQT, Philips Hughes. Yeah, there's even energy management. I thought there was an app section. There we go. No, I think it's called Blueprints or something. Like, you can do a lot with Home Assistant. It's pretty in depth. I think that's what they call them, blueprints. Application notifications, action, washing machine, clothes dryer, dishwasher, etc. Bathroom immediate exhaust fan, alarm system with Zigbee. Yeah, it's Home Assistant's crazy. Woodpecker. Explore, maybe. Be smart. Gen 2? Oh, nice. Based. Encrypted personal finance, crypto. FreeBSD ports. Nice. Boo. Next. Windscribe, Wi-Fi exporter, bike bridge, companion app for the e-bike and components. That's cool. There's Quad. We'll do today. Uncloud, a lightweight tool for deploying and managing containers applications across networks of Docker hosts, bridging that between Docker and Kubernetes. That's cool. Uncloud is a lightweight clustering and container organization tool that lets you deploy and manage web apps across cloud VMs and bare metal with minimalized cluster management overhead. Creates a secure WildGuard mesh network between your Docker host and provides automatic service discovery, load balancing, ingress with HTTPS, and simple CLI commands to manage your apps. Deploy anywhere. Docker Compose for another Docker Compose. Zero downtime deployments, unregistered integration, build and push your Docker images directly to your machines without external registry. Okay. Automatic HTTPS, built-in caddy reverse properly handling the TL server in case reversing news. Okay. Stay simple as you grow. Build with proven primitives. Wow, that's kind of cool. I'll have to bookmark this. Bund, React, empower the web community, invite more build. Links. Huh. Hierarchical reasoning model offense release, HRM. Wow, that's very cool. Carrier grade NAT, also known as a large scale CNAT. Oh, interesting. Alright, guys, it's EP time. I will do a longer stream as I usually do on Sunday. Appreciate y'all stopping by. Remember to don't eat yellow snow, and remember that you can't visit Antarctica legally. I'll see you guys in the next video. Remember to argue in the comments about what's the best Pop-Tart flavor so that YouTube knows I am a real person.